When upgrading an electrical service from a 60-amp fuse box to a 125-amp electrical panel, several steps and considerations are critical. Firstly, contacting the utility company is important. Inform them of the service upgrade and schedule the meter replacement. Typically, the utility company is responsible for removing the old meter, installing the new meter socket, and installing the new meter itself. Secondly, obtain a permit from the local building department before starting any electrical work. Next, install the new 125-amp electrical box. Mount the new electrical panel and run new wires from the panel to the service drop. Temporarily splicing into the drop involves turning off the power at the service drop and making a temporary connection to provide power during the inspection. This temporary connection enables the electrical inspector to verify the proper operation of the newly installed panel and wiring. If the utility company requires it, install knife fuses. These fuses should be rated for the appropriate amperage, typically 125 amps, matching the new service capacity. Knife fuses provide temporary overcurrent protection while the permanent meter is not yet installed. Schedule an electrical inspection with the local building department once the wiring and temporary connections are complete. Once the electrical inspection is passed, the utility company will schedule a time to install the new meter. This finalizes the service upgrade. The utility company usually installs the meter mask or metering socket along with the new meter. Knife fuses provide temporary protection until the permanent meter is installed. Throughout this process, adherence to all local electrical codes and manufacturers' instructions is paramount. Regarding specific steps, firstly, coordinate with the utility to disconnect the existing service. This ensures safe working conditions while replacing the meter socket and upgrading the service panel. Secondly, after the utility disconnects the power, carefully remove the old meter socket. Inspect the service entrance conductors for any signs of damage or wear and replace them if necessary to ensure a reliable and safe electrical connection. Next, mount the new meter socket, ensuring it is properly grounded and securely attached to the building. The grounding is vital for safety and proper operation of electrical systems. Connect the service entrance conductors to the new meter socket following the manufacturer's instructions and local electrical codes. Proper connections are crucial to prevent loose connections or arcing. Install the new 125-amp electrical panel, ensuring it is properly grounded and securely mounted. Connect the service entrance conductors from the meter socket to the main breaker in the new electrical panel. The main breaker provides overcurrent protection for the entire electrical system. Install branch circuit breakers in the new electrical panel to protect individual circuits throughout the house. Label each breaker clearly to indicate which circuits they control. After installing the new panel, temporarily splice into the drop to provide power for the electrical inspection. Use appropriately sized connectors and ensure the connections are well insulated. If the utility requires knife fuses, install them in a suitable enclosure between the temporary splice and the new electrical panel. The knife fuses provide overcurrent protection during the temporary connection. Schedule an electrical inspection with the local building department to verify that the service upgrade meets all applicable codes and regulations. After the inspection, the utility company will install the new meter, completing the service upgrade. Always follow all local electrical codes and the National Electrical Code, or NEC, when performing electrical work. Ensure all work is performed safely and correctly to protect against electrical hazards. Specific NEC articles provide guidance on service upgrades. For example, NEC Article 230 covers service entrances, providing requirements for conductor sizing, overcurrent protection, and grounding. Additionally, NEC Article 250 provides detailed requirements for grounding and bonding to ensure electrical safety. NEC Table 310.16 and subsequent tables and articles should be used to determine the ampacity of conductors based on their size, insulation type, and insulation method. This ensures conductors are adequately sized for the intended load. Consult the NEC for the most up-to-date requirements and local amendments. Working with electricity can be dangerous, so it's recommended that only qualified and licensed electricians perform service upgrades and electrical work. Firstly, planning is paramount. Before commencing any work, a thorough assessment of the existing electrical system must be undertaken. This includes evaluating the current service capacity, identifying any existing code violations, and determining the new load requirements. Load calculations are essential to ensure that the upgraded service can adequately handle the increased demand. Secondly, safety measures are crucial. Prior to any electrical work, the power supply must be completely disconnected to prevent accidental electrocution or injury. Appropriate personal protective equipment, including insulated gloves, safety glasses, and appropriate clothing, must be worn at all times. Thirdly, grounding and bonding. Proper grounding and bonding are vital for electrical safety. The grounding system provides a path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of shock. Fourthly, conductor sizing and selection. Proper conductor sizing is essential to prevent overheating and voltage drop. Conductors must be sized according to the load they will carry, considering factors such as ambient temperature and the number of conductors in a raceway. The NEC provides tables and guidelines for determining the appropriate conductor size for various applications. Fifthly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The overcurrent protection device must be properly sized to match the ampacity of the conductors it protects. Sixthly, wiring methods. Proper wiring methods must be followed to ensure the safety and reliability of the electrical system. This includes using approved wiring materials, properly supporting and securing conductors, and protecting conductors from physical damage. Seventhly, electrical boxes and enclosures. Electrical boxes and enclosures must be used to protect electrical connections and devices. Boxes and enclosures must be properly sized and installed to provide adequate space for conductors and devices. Eighthly, labeling and identification. All electrical circuits and equipment must be properly labeled and identified to facilitate troubleshooting and maintenance. This includes labeling circuit breakers, switches, and outlets. Ninthly, inspection and testing. After completing the electrical work, a thorough inspection and testing must be conducted to verify that the installation meets all applicable codes and standards. This includes testing for proper grounding, insulation resistance, and circuit polarity. Tenthly, documentation. Accurate documentation of the electrical installation is essential for future maintenance and troubleshooting. This includes creating a wiring diagram and maintaining records of all materials and equipment used. Regarding the temporary splice, it is crucial to ensure that the temporary connection is made in a safe and code-compliant manner. The temporary splice must be properly insulated and protected from physical damage. If knife fuses are used, they must be installed in an approved enclosure. Additionally, the temporary splice must be removed as soon as the permanent meter is installed by the utility company. The process of obtaining a permit typically involves submitting an application to the local building department, providing detailed information about the scope of the electrical work, and paying the required fees. The building department will review the application and issue a permit if the proposed work meets all applicable codes and regulations. The electrical inspection is conducted by a qualified electrical inspector who will verify that the electrical installation meets all applicable codes and standards. The inspector will examine the wiring, grounding, overcurrent protection, and other aspects of the electrical system. If any deficiencies are found, the inspector will issue a notice of violation requiring the electrician to correct the issues before the installation can be approved. The utility company typically has specific requirements for meter sockets, including the type of socket, the mounting height, and the clearance around the socket. The utility company may also require the electrician to install a disconnect switch adjacent to the meter socket. The purpose of the mask or metering socket is to provide a secure and weatherproof enclosure for the electrical meter. The mask also helps to prevent tampering with the meter. It is important to follow all manufacturer's instructions when installing the new meter socket and electrical panel. The manufacturer's instructions provide detailed information about the proper installation procedures and safety precautions. Additionally, it is important to use the correct tools and equipment when performing electrical work. Using the wrong tools can damage the electrical components or create a safety hazard. Electrical work can be dangerous if not performed properly. It is important to take all necessary safety precautions and follow all applicable codes and regulations. If you are not comfortable performing electrical work yourself, it is best to hire a qualified and licensed electrician. The electrician will have the knowledge, skills, and experience to perform the work safely and correctly. In summary, upgrading an electrical service requires careful planning, attention to detail, and adherence to all applicable codes and regulations. By following the steps outlined in this video, you can ensure that the service upgrade is performed safely and correctly. The temporary splice and knife fuses are temporary measures to provide power during the inspection. These temporary connections must be removed as soon as the utility company installs the new meter. Always prioritize safety when working with electricity. If you are unsure about any aspect of the electrical work, consult a qualified and licensed electrician. Remember to always energize circuits before working on them, use appropriate personal protective equipment, and follow all applicable codes and regulations. In addition to the steps outlined above, it is also important to consider the following factors when upgrading an electrical service. Firstly, the size of the service entrance conductors. Secondly, the capacity of the main breaker. Thirdly, the number of branch circuits needed. And fourthly, the location of the electrical panel. The service entrance conductors must be sized to carry the total load of the electrical system. The main breaker must be sized to protect the service entrance conductors from overloads. The number of branch circuits needed will depend on the size and layout of the house. The electrical panel should be located in a convenient and accessible location. Upgrading an electrical service can be a complex and challenging task. However, by following the steps outlined in this video and taking the necessary safety precautions, you can ensure that the service upgrade is performed safely and correctly. The key takeaways are: firstly, contact the utility company. Secondly, obtain a permit. Thirdly, install the electrical box. Fourthly, temporarily splice into the drop. Fifthly, install knife fuses if required. Sixthly, schedule an inspection. And seventhly, the utility company will install the meter. And remember, always prioritize safety.